Hello everyone, welcome to MMBS111 Introductory Microbiology. This is mini lecture 11.3. We're going to be discussing epidemiology and the study of disease in populations. There are 4 learning outcomes for this mini lecture. First, summarize the goals of epidemiology and differentiate it from traditional medical practice. 2, explain what is meant by a disease being notifiable or reportable and provide examples. 3, define incidence and prevalence and explain the difference between them. And finally, discuss the 3 major types of epidemics and identify the epidemic curve associated with each. So epidemiology is the study of the frequency and distribution of disease and other health-related factors in populations. So we don't just want to know how many people are infected, but we also want to know how those infections are distributed through a population. There are things like geography or age. We want to know how particular infections are distributed through the population. It involves a number of different disciplines beyond microbiology. An epidemiologist must have a good understanding of anatomy and physiology, immunology, medicine, psychology, sociology, ecology, and statistics. So it incorporates a number of different disciplines in order to understand how disease originates, how it spreads, how it's distributed. And it considers all forms of disease, not just diseases caused by microbes, but all diseases that affect the population, including heart disease, cancer, drug addiction, and mental illness. Some techniques used by epidemiologists are to track behaviors such as exercise or smoking, because those behaviors relate to certain diseases. Also, using clues within the population to identify the causative agent, what's the pathology of the disease, sources of the disease, how it is transmitted. Epidemiologists also track the numbers and distribution of cases of disease in a community to better understand the disease itself. And the outcomes of these studies help public health departments develop prevention and treatment programs and the basis for predictions about diseases and in particular epidemics. So data that is tracked is kept for a large number of diseases, and this data assists these organizations in making predictions about the location and the spread of certain diseases, and it helps us to make predictions about epidemics. Some diseases are required to be reported either to state departments of health or to the CDC, and that reporting can vary depending on the organism. So some organisms require immediate reporting as soon as the agent is identified. Others are less serious or I don't know what to say, necessary. Anyways, there is more time allowed for the reporting of those agents. So anthrax, botulism, rabies, a number of other infectious agents, those are immediate reporting. As soon as the agent is identified, it must be reported. Cholera, measles, and SARS, as well as a number of other agents, are allowed 1 day for reporting. MRSA, syphilis, HIV, these are 3-day routine reporting. So they are diseases that must still be reported, but there's greater time allowed in that reporting, and it's routine. When we're looking at statistics related to epidemiology, there are some terms that we need to understand. And the first is prevalence. When we're talking about the prevalence of the disease, we're talking about the total number of existing cases with respect to the entire population. And this number is generally reported as a percentage. So the prevalence of a disease might be a certain percent of the total population. So maybe HIV, the prevalence of HIV is 2% of the world population. I don't know if that's it, but that's how we report prevalence or refer to prevalence. When we're talking about incidence, this is the number of new cases in a certain time period. So generally this is reported as per 100,000 persons. So we might say the incidence of HIV is 5 per 100,000. So there are 5 new cases for every 100,000 people in a certain period of time. Some other statistics that epidemiologists are concerned with are the rates of disease regarding sex or gender. So we want to know the prevalence and incidence of certain diseases in men and women. Is there a greater prevalence or greater incidence related to gender or race? So how does ethnicity affect prevalence and incidence? And then the geographical region. Are certain locations at greater risk for certain diseases? Mortality rate measures the total number of deaths in a population due to a certain disease. And since the development of modern medicine, overall death rate from infectious diseases has dropped quite a bit. However, the number of persons afflicted with infectious diseases has remained high. And this just has to do with numbers. As the human population on Earth increases, there are more individuals who are available to infect. So the morbidity rate, or the number of individuals infected, continues to be high. These are the 3 main types of epidemics and the epidemic curves associated with them. The first is a point source epidemic, and a point source is an epidemic that involves a single source. The victims were all exposed to the infectious agent from the same source. We often see this with foodborne illnesses. Maybe there's a birthday party and the egg salad is contaminated with salmonella. Everyone at the party has egg salad, and then over this short period of time, we see this spike in salmonella cases. And then the number returns to normal. The next type of epidemic is a common source epidemic. And this is still an epidemic that evolves from the same source. So there is a single source of infection. However, this type of infection occurs over a longer period of time. So one example might be a contaminated water source in a community, and we see over a longer period of time the numbers of individuals or the numbers of cases increase. So we have a few spikes, and this epidemic, unlike the point source epidemic, occurs over a much greater length of time. The final type of epidemic is a propagated epidemic, and these epidemics are caused by communicable diseases. So these are infectious agents that are passed from person to person. So you can see in the graph here that we have an index case labeled. The index case is the case that first healthcare individuals or organizations become aware of the case. So this is probably the first person that may have sought medical treatment. And then over the course of a number of days, we see several different spikes, and the number of cases continues to increase with the subsequent spikes in this epidemic. And that makes sense because as one individual comes in contact with a few, and those people become infected, and then they come in contact with a number more people, and those people become infected, and then they come in contact with a number more people. So the source of the epidemic propagates. It continues to be passed from individual to individual. Some other statistics involved in epidemiology, we've already talked about the index case, are the occurrences of epidemics. So an endemic infection or endemic occurrence of a disease is one that demonstrates a steady frequency of cases over a long period of time in a particular geographic area. So you can see in the image on the right, the green map shows endemic occurrence. We have this general location, and we have essentially a constant or steady number of cases over a period of time, over years or months. Then we have sporadic epidemics, and sporadic occurrences are occasional cases that are reported at irregular intervals and in random locations. So there's no pattern to a sporadic occurrence. We get varied cases in various places. Epidemic occurrence, you can see on the map, we have cases of a particular infectious agent that are beyond what is expected for a population. And generally they happen in pockets, in specific locations, and the time period isn't necessarily defined. In pandemic occurrences, we get a spread of an epidemic across continents. So we might have an origination of an infectious agent, maybe an epidemic that we've identified in a particular location, maybe someplace in the United States, and then we see that epidemic spread to other locations on different continents. And that is the end of section 11.3. These are our checking in questions, so make sure you go through these and that you can answer them correctly. Also, make sure that you review the learning outcomes and be certain that you can respond to those correctly. Here's our critical thinking question. We have an epidemic curve on the left, and based on that curve, you need to determine what type of epidemic is displayed there. And also give an example. What would be an example of this type of epidemic? And once you've constructed a good response and you think you understand that, come back and check your answer on the answer slide. And hopefully this video was helpful.